It's always amazing to have this explosion of flavors from a single bite of cheese. The problem I often have is I bought too many pieces of cheeses. I want to half of each, and I have to store them in the fridge. To keep the cheese as fresh as possible, I aim to cut each piece into equal-sized halves while minimizing the exposed surface area. What would be the optimal way to cut them? Let's take this camembert as an example. The solution is quite simple for this disc-shaped camembert. Simply cut it through the center of the camembert. The problem gets more complicated when you have this kind of triangular or fan-shaped brie. Actually, the optimal cut is a little bit unusual. So cutting it along the radius or cutting it horizontally is no longer the optimal cut. The optimal cut actually requires you to make a curved cut. The problem gets more complex in a higher dimensional space. Imagine you have a 50-dimensional object. What would be the optimal cut that minimizes the exposed surface area? This problem is known as an isoperimetric problem, which dates back to ancient Greece. In a sense, it studies whether an object has a bottleneck, and those bottlenecks are the main obstacles for dynamical systems to run fast. Imagine I start eating this cheese in my office. How long will it take for my colleague next door to notice? The travel of the smell of the cheese is a dynamical system here. If I try to close my door, it will create a bottleneck and it will take longer for my colleague to notice. And that's about the geometry of the problem. Of course, if I get a very strong cheese, my colleague will notice it very fast. And that is about the intrinsic properties or the algorithmic part of the dynamical system. Only by comprehending both the geometric aspect and algorithmic aspect of the problem, we understand the system well.
Here comes the cheese board.
And providing quantitative understandings of both parts for problems that arise in the statistical context is my research at ETH.